Morning, guys. Today I'm going to talk about chapter 5 and functions and graph. Okay. Um, in my previous two videos, I talked about how you can sketch your quadratic equations using completing the square method, and I also talked about how you can actually uh, sketch your graphs using factorization method for quadratic equations. And today I'm going to talk about how you can graph power functions. Alright, so without further ado, let me go to the next slide and illustrate with an example. So over here, I already have my x and y axis. Alright, so let me start off with y is equal to x to the power of. So let's start off with y is equal to 2. Right, so this is also called a constant function. Okay, I will illustrate to you why this is called a constant function. Okay, so let me label my x and y axis. So over here is 2, 3, 4. Is no, I must use 4, 6. I hope you can see over here. I take one. I take one unit here is 2. Right, so therefore one unit here is another 2, so you should have 0, 2, 4, 6, and subsequently. And for the negative portion of your y-axis, you should have -2, 4. And over here you can actually choose 2, 4, 6 as well. -2, -4. Okay, I will stop here, and I'm going to sketch y is equal to 2. So you can actually see what you can actually see that for this constant function, regardless of the x values, okay, the y is always 2. Am I right? So this is the key here. So regardless of the x values, y is always 2. So which means when your x is 0, your y is 2. When your x is 2, your y is still 2. When your x is 4, your y is still 2. So it's always 2 regardless, right? So with this point, I can actually draw my y is equal to 2. So this is my y is equal to 2, which is a constant function, right? So let me this line thicker, right? So this is my y equals to 2, okay, which is also a constant function, right? Now let me give you another example. So let's draw this y is equal to -3. Okay, so I hope you can see this is also a constant function. Okay, so regardless of your x values, your y is always equal to your -3, right? So regardless of your x values, it's always -3, 3, and 3 for your y values. So with these 3 points, you can actually sketch. Alright, so we change the color to differentiate this from the above. Okay, so this is your y is equal to your negative 3. Alright, so let me start off with the most basic one first, which is your constant function. Okay, so let me move on. So similarly, you have x and y axis here, and let me label two of them first. And for this example, I'm going to draw y is equal to x. Okay, so over here you have a linear function. Okay, just now you have a constant function. Okay, just now you have a constant function here, and regardless of your x values, your y value is always the same. Okay, so over here you have a linear function. So let's look at what a linear function is. So a linear function is when your power of x is 1. Okay, so when your power of x is 1, so it's called a linear function. So let's start with it. So how can we sketch our y is equal to x? So before we move on, let's label the x and y axis first. Alright, so now over here, so if you can actually test it with table. So let me get this table out. This is not what I want. This is not what I want. Yes, so I will just move it here, or rather let me move it right below here. Okay, so I hope you can see. So when your x is equal to -1, what's your y? Your y is also -1, right? So when your x is equal to 0, your y is equal to 0. So similarly, if your x is equal to 1, and then your y is equal to 1, and your x is equal to 2, and your y is equal to 2. Okay, because of this, y is equal to x. Okay, whatever your value of x, the y value is the same as x. So I have my x is equal to -1, which covers the negative side of the x-axis, and I have my x is equal to 0. Okay, so it covers the origin, and I have my 1 and 2 for my x, which covers the positive region of the x-axis here. Okay, so without further ado, let me continue to plot these points first. So -1 of x, so I will get -1 for y, which is somewhere here. 0, 0, 1 and 1, 2 and 2. Alright, so I have 4 points, and this allows me to link them up. Let me link them up. This is not what I want. I want a straight line. So start from here. Let's link them up. We make it thicker. Okay, can you see? Alright, so you have a straight line already. Okay, so this is your y is equal to x. Okay, so that's how you can draw your y is equal to x, which is a linear function here, and the power of your 1, okay, your power of your x here is 1. Okay, so now let's move on to the next slide. Okay, so I hope you still remember. Okay, y is equal to x squared is my example here, and this is a quadratic equation. Okay, this is a quadratic equation. All right, so I'm using QE here. So quadratic equation. Okay, if you have been following my video so far, so you know what a quadratic equation is. So the highest power of x is 2. Okay, this is the first feature, and the second feature is there is an equal sign. Alright, so these are the two features of a quadratic equation. So this is definitely a quadratic equation because your power, the highest power of x is 2, and then you have an equal sign here. Okay, so let me continue to sketch this y is equal to x to the power of 2 out. Okay, so before I can draw anything, so let me start off with a table. So with the table and the values in the table, you can start to sketch your graph. Alright, so over here, let me just park it here. So I have my x, I have my y here. Alright, then let me cover the negative part. So I have my -2 and -1 and 0, 0 and 1. Alright, so that's about it. So for this, y is equal to x over 2. When your x is -2, so you have a bracket -2 to the power of 2, so you are supposed to get 4. Alright, and then for this, you're supposed to get 1. Okay, but if you're wondering why I get a positive number, because the y is in bracket -2. Okay, so over here you get your 4. Alright, so similarly, for this value, so y is equal to bracket -1 to the power of 2. So you're supposed to get positive. Alright, so you input your x is equal to 0 into it, you get 0. So if you input your x is equal to 1 to the equation, you will get 1. So similarly, if you have a x is equal to 2, it's supposed to end up with 4. Alright, so you have all these points. So let me label the x and y axis. So start off with 0, 2, 4, 6, 2, 4, 6, 2, 2. Okay, 4. Okay, so let me start off with my -2. So when x is -2, and I get 4, right? And -1 and 1, -1 and 1 is somewhere here. 0 and 0 is here. 1 and 1, 2 and 4. Okay, so I can start to sketch this quadratic equation. Alright, so let me link up the right hand side. Okay, and now let me link up the left hand side. Okay, I always have problem linking up the left hand side, so bear with me. So let me start from. Okay, this is better. Okay, this is so much better. So this is your y is equal to x to the power of 2. Okay, and this is a quadratic function. Okay, so that's how you can actually draw this quadratic equation. But I don't want to stop here. I would like to continue to the next slide, and over here I'm going to draw your y is equal to your x to the power of 3. Alright, oh no, not -3, x to the power of 3. Alright, so let me give myself some values before I can draw them out. So I have my x and y, and let me start off from -3. So if I have -3 for my x, if you input it into this, you are supposed to get -27. Alright, so if you input x is equal to -2, you will get -8. So okay, so subsequently, so I will just key in all the values for you. So you can also go back and check it out on your own. So I will just give you the value here. Right? Okay, so I have these points. So now before I continue, I would like to label my x and y axis. Alright, so I should have um okay, my x is equal to 1, 2, and 3. -1, -2, and -3. So seems like I need to extend this x-axis. Let me extend it. Alright, and for this y-axis, I'm supposed to have 10, 20, 30, and then I'm supposed to have -10, 20, 30. Alright, so seems like I also need to extend my y-axis. Okay, so another thing to note here is always give yourself some flexibility to extend your x or your y-axis. Alright, so let me plot these points out. And it's -3, I'm supposed to get -27. So -27 is somewhere here. And -2 and -8, so it's somewhere here. -1 and -1, so just see over here is how many unit? 1, 2, 4. So it's 2/5, so it's somewhere. 0 is 0. So similarly, 1 and 1. And you have your 2 and 8, so it's so this is your 2/5, 5, and then your 3 and 27, so it's somewhere. Alright, so what you need to do is link up the points. So let me link up my points for this right hand side of the x-axis. Let me see if I have a better approach to link up the points. Let me try with this first. So link it up, link it up, link it up. I should stop here. Alright, so move up a bit. Alright, so okay, over here this part, right, this particular part is not very good, so let me do a better one. Here, here, I will stop here. Alright, and then for this portion, I'm going to start with my just link up manually. Alright, and then now what I have is I need to link up the points for the negative portion of the x-axis. So let me link up this part. Alright, okay, so with this, I can actually start to use this, link up the rest. Okay, so this is your y is equal to your x to the power 3 function. Okay, and by the way, this is a qubit function. Alright, so with this, I would like to conclude this graphs of our function. So what have we learned so far is we have we started with our constant function, and next is our linear function. This is our linear function, and this is our constant function. And we continue with our quadratic equation or quadratic function. And last but not least, over here, you have your cubic function. Alright, so with this, we have learned how to sketch all this. So, thank you so much. Bye.